Good evening, students. I'll start with the class. In the previous class, we had seen the Stokes law. And today's topic is variation of pressure with depth. If any object is there in the fluid and all, what will happen to its pressure? So for that, we'll just draw one diagram. Okay, so in this container, so this is a container. In this, we will assume some fluid is there. We'll just write, because it's not there in the notes, I'll give. Consider a container or consider fluid at rest in a container. Okay. Now inside this, we'll consider a small column. This much on the area we'll see. We'll mark 2 points over here. This is point 1 and this is point 2. So let pressure at point 1 be P1 and let pressure at point 2 be P2. If you assume anything inside, there's some fluid. Obviously, any object when you place inside a fluid, we have seen that there's always a pressure exerted on it from that fluid. Okay, so we are just assuming only 2 points. So obviously this fluid is exerting pressure at point 1 and exerting pressure at point 2 also. So we'll assume at point 1 let the pressure be P1 and at P2 let the pressure be this P2. Okay, now suppose this is an object, under that also there's one more, which is always the force, under the force of gravity, that will be mg. Its weight will always try to pull this down because of gravity. So always there's a downward force acting due to gravity. Because now this is closed. Suppose if you just open this, what is going to happen? All the fluid will start flowing. Why is it happening? Because of the weight of the fluid, because it is under gravity. So there's a downward force mg. And let us assume this is of height h. Okay. So this is like a column of fluid only, we are assuming. Small area of this inside the fluid, cylindrical part of height h. Now, what is pressure? Pressure is nothing but always force upon area. Pressure will be always force upon area. So force is what? Always pressure into area. So over here P1 will be what? Always equals to P1 into A will be equals to F1. Same way P2 into A will be equals to F2. So now you know which all are acting. I'm just drawing this out. So this will be F1, this will be F2, there is mg. So these are all the total forces acting on that particular cylindrical column. What is pressure? Pressure is nothing but force acting on that particular area. So because of this pressure, there is a force which has been exerted. So now you know that for any object or anything, any force, as per this upward forces will always be equal to downward force. So which all are the upward forces? F2. There is only one upward force. In downward forces, there are two of them. This will be F1 plus mg. So what is F1? F1 is this P1 into A, and F2 is what? P2 into A. So I'll bring this on one side. A is common. We always know that mass is, or density is mass upon volume. So mass will be what? Density into volume is equals to mass. Again, volume is what? Area into height. So just put it here. Density is always mass upon volume. So density into volume is mass. Volume is what? Area into its height. So just put it here. P2 minus P1 rho AH into G. A and A will cancel. So P2 minus P1 is equals to rho HG. Put this in the box. So anytime, any problem or something later, any concept, if you want to know pressure, so what is this particular column? So this is like one piece inside a fluid, only this particular this. So if I have any fluid and I want to calculate pressure for this particular area, means this particular column, this is called as a liquid column. So this liquid column will always have some pressure. The pressure of liquid column is always equals to rho Hg or rho Gh, whichever side you want to write, no problem. So remember this, pressure of any liquid column is equals to rho Gh, where rho is the density of the fluid, G is gravity, and H is height of the liquid column. Okay, next one. We'll see what is a barometer now. What is a mercury barometer? This bar means pressure. It is a device used to measure atmospheric pressure. Now, what is this atmospheric pressure? Suppose if this is the Earth, you know that it is always surrounded by a layer of atmosphere. This is the atmosphere. Why is it in this shape? Why is it not everywhere in the universe? Why is it only around the Earth in this particular shape, not a square shape and all? Because all the molecules of this air are bounded together by the gravity. Okay, from all the sides, it is being pulled by the gravity. So there is always a pressure which is created. So there is always a pressure on the air which has been created due to gravity, and that's why it takes up that shape around the Earth. If there was no gravity, maybe that all the molecules would be floating anywhere in the universe. So this pressure is called as atmospheric pressure. Okay, now how to derive means how to find out how much is the atmospheric pressure. So there was a scientist called as Torricelli. Okay, there was a scientist called as Torricelli. So he did one experiment. So he took some particular fluid. He took one special kind of a fluid here. And then he took one small tube. Okay, this is closed at one end and this side it is open. So he filled up this tube with mercury. Okay. Now what he did is this side it is open. So what he did, he just put this tube inverted in this. So this side became closed. Okay. So all the mercury which is there inside, not everything will flow in the fluid. This whole mercury did not flow in the fluid. Only certain part. So this much got empty and this much remained. So now this whatever above the fluid level, that is height h, suppose. Now he tried this same cylinder of different sizes. Even if you put a bigger one, even if you put a bigger cylinder also, he noticed that this height, finally this height, whatever is of the liquid is coming same as this. No matter how big the tube is, the height of this particular mercury finally which remains is always same. He tried for various sizes and every single time he got the same height. Okay, and he calculated the height for all the experiments, and that height turned out to be 760 mm, which is same as 760 centimeter or 0.76 meters. So he saw that the mercury level or the mercury height always remains same. Why was this happening is because now this is height. So this is considered like a liquid column, suppose. Always wherever any object will, there's atmosphere surrounded by us, always there is an atmospheric pressure acting on an open surface area. If you notice that there is a atmospheric pressure which is been applied on the liquid, always by default it is always there because this liquid is open to the atmosphere. Now what about this? Inside this, what he assumed is there are mercury vapors which are negligible. So it's almost equal to vacuum. He considered it to be equal to vacuum. So the mercury when it goes down, no, becomes empty here, but there is no air which will come inside here. Okay, so this remains vacant without any slight mercury vapors might be there which can be negligible because they are very scanty of them. It doesn't create any pressure on this. So here inside this pressure is zero. If there was air filled up here, then here also pressure would have been applied on the on that column, on that liquid. But he is assuming that there is a vacuum created, and here there is no pressure. But if this, suppose if this tube was open, definitely there would be pressure acting here also. So anything open which comes in contact with the atmosphere will have atmospheric pressure. So now what he did is he wanted to calculate how much is this atmospheric pressure. So why is it coming only till this level is because the moment it becomes equals to this pressure, outer pressure and inner pressure, it stops. Before that, if it was up and this was less, finally it has to come in equilibrium with the outer pressure. So the inner pressure should always be equal to the outer pressure. Okay, or the other way around, I'll write outer pressure should be equal to inner pressure. So which is the outer pressure acting on this is atmospheric pressure. Inner pressure we have to calculate now. So inner pressure is what? Of this liquid column plus this, is there anything here? No, this will be anyways zero. So we'll consider only this much only pressure which is there in the liquid column, because even this liquid, this particular is exerting some pressure on this line. This whole liquid mercury is exerting some pressure on this line. So this outer pressure is always equal to inner. So just now we have derived one formula. What is the pressure for a liquid column? That is given as rho G H. Okay, it is given by the formula rho gh. Any liquid column will always have the pressure given as rho gh. Suppose if there was any atmospheric pressure outside in this, then we have to write by plus Pa. If this was filled up with air, then it would be always this pressure plus this pressure. But right now this is not there, this is not open. So that's why, because of vacuum, there's no pressure. We are assuming it to be anyway 0. Now you wanted to see how much density and all, he calculated the value. So 1 mm of mercury, 1 was 1 torr. He named after him. This is the unit because his name was Torricelli. 1 mm of mercury, he said, equals to 1 torr. So that unit normally we don't use, so we use the atmospheric pressure unit, the standard unit. So he calculated that is turning out to be 760 torrs. So that he made it into SI unit. Okay, still it is in terms of torr, not actually it is not SI unit. Now what is this pressures unit? Pressures unit is pascals. So he wanted to convert them into pascals. Okay, this torr is after his name, so the universe has not accepted. That is standard unit it needs. But this is according to his experiment. Pa is equals to 760 torr. Okay, now we'll calculate as per this. Pa will be rho gh. So the density of the fluid he took as into 9.8. Okay, substitute here now. Anyway, g is 9.8 and height we have just seen, that is 0.76. He got this as fixed term. This is fixed. Every experiment with no matter which tube he used, he always got this h fixed. So substitute here. It turned out to be 1.013 into 10 raised to 5 Pascal. So this is standard unit. This is Pa is for atmospheric pressure and this is proper Pa is for Pascals. And this means atmospheric pressure. Don't get confused between both Pa, Pa. This is a small letter P for subscript and this is proper Pa. If you have a line, then this is like this. And Pascals is like this. This is a subscript and this is a proper letter for Pascal. So atmospheric pressure is always equals to 1.013. And that is this system, okay, was based on the barometer. Use this mercury barometer. How much is the atmospheric pressure? 1.013 into 10 raised to 5. Who derived this? Torricelli. Next one is a open tube manometer. Or also called as a U tube. Not the normal because of the shape U, okay. So what is this used for? Device used to measure . pressure difference. You want to check difference between two things, pressure difference, then you can use the manometer. On what this system it works on, first we'll just have closed one. Suppose if you have a box like this, same height, huh? Because of the shape U, it is called UT. So on what basis it works is, suppose there is a liquid filled in this. There is some liquid filled or fluid filled in this. Now there is a pressure over here, and there is a pressure on this side also. Now suppose if this pressure we want to calculate this. So now pressure, suppose P1 is more than P2. This side the pressure is more. So what is going to happen? This pressure, whenever there's a pressure, what is going to happen? If there's a pressure, you are applying some pressure, suppose here from this side. So this pressure will travel here and it will try to push the liquid down. This pressure is more. So what is going to happen? First, suppose if both the pressures are equal, they will be at the same height. But now what is going to happen? If this pressure is more than this fellow will be pushing down the liquid. Maybe here it will reach here. But this side it will come up that much. So how much ever is coming up, maybe this much it came up because of this pressure. More the pressure, more the liquid will come up. So that is how they will measure the pressure. How much more the height it will be compared to your original height. If there is less pressure, then it will be less liquid displaced. Imagine like you are going on increasing the pressure means then the height will keep on increasing. So that how much ever water got displaced because of this, how much it came up, so that considered to be H. So now that is the dark, we are going to be a liquid column. Okay, so how many pressures are there over here now? Over here at this point, how many pressures are there? One is coming from this side P2 and one is, so total pressure will be equals to how much? Pressure due to liquid column plus P2. That will be rho GH, that is P1. No? This P1 will be equals to nothing but pressure over here plus this. So then you can always calculate the difference. P1 minus P2 will be rho GH. Now this was considering, suppose this was closed one. Now in the next step, what I'll do is I'll just, as per the name, open. Hope you all have understood this concept. See, what has happened? This has been taken as a U. There's some liquid filled up. So I want to measure the pressure difference, P1 minus P2. So there's some pressure which has been applying from this side. Maybe it is creating some pressure. So this pressure will travel here. Now this water will go down. This side it will come up. So this, how much ever is coming up, is considered to be that liquid column of height h. Now this side has a pressure. Okay, so there's a difference. So every liquid column, I told you, will always have some pressure, and that pressure due to liquid column is given by the formula rho gh. Now in the previous, when we were doing a barometer, when I was considering that liquid column, why I did not consider any pressure from top? Because we had assumed this was a vacuum. So I told you this pressure from top on this liquid column will be assumed to be 0. Okay, but now this is not vacuum. There is some pressure, the P2, which is coming on here. So total will be what? This plus this. Okay, so upward will be equals to this plus this. So P1 is equals to pressure due to liquid column plus this total pressure. And that's how you get P1 minus P2. You can always calculate device used to measure pressure difference. So based on how much height, gravity will be fixed, density of the fluid will be fixed. So more the height, more will be the pressure difference. If both pressures are equal, then this will be 0. Height will be 0. Now that open one. So for open tube, what I'll do is I'll just open this up. Now this, it is open to the atmosphere. Now can anyone tell me what I have to replace this with? Can anyone tell me what will be the pressure coming here? This is open now. Can anyone tell me what is the pressure going to be here? It is open to the atmosphere. So what pressure from the atmosphere? What letter I'll put there? Answer fast. Whenever any liquid is open to the atmosphere, what pressure I said? Please answer. Start answering fast. Which attempt something, even if it's wrong, I will correct. No problem. Which pressure is going to come out? What I'm going to write here instead of P2 now? What is the letter given? If any pressure is coming from the atmosphere? You'll tell. I am not continuing fast. Which pressure, if this is exposed to the atmosphere, which pressure? Just one letter word. This you have to mention before I start taking names quickly. Just attempt.
Atmospheric pressure.
Yes, atmospheric pressure, no? So that will be, you just have to replace it by PA. Okay, now whenever the tube is open, the only pressure which is coming is PA from the atmosphere. So the formula will only make a difference is, instead of this, it will be PA for open tube. If it's a closed tube, then it will be P1 minus P2. If it's an open tube, the atmospheric pressure will come. This is the formula for a open tube manometer. And what is going to happen? This atmospheric pressure will be fixed. That is 1.1.0. This into 10 raised to 5. This is fixed. Density also fixed. Gravity is also fixed. Only if you know the height, then you know what is the pressure inside this. So it can be used as a pressure meter. You want to measure pressure of anything, whatever is here, this is fixed, this value you know. So based on this, the height will, the only thing you have to measure is the height. So if something is 10 centimeter, so convert it into meters, put it here, you will always get the pressure what is there inside. So all these are used devices used to measure pressure. Barometer, then manometer. Next is speed of efflux from Torricelli's law. Double arrow. So we have to calculate what is the speed of efflux, means flow. Outward flow of fluid. If the fluid is flowing out, no, from a container, then it is called efflux. He didn't tried one experiment. He took one container. Suppose there's a fluid. Okay. He made one hole over here. Suppose if he made a hole and see how much water is flowing out and calculated the speed. The speed over here. First he tried here. He calculated some speed. Then he tried here, maybe. Then again some water will flow out. He checked the speed of that fluid falling out. And then he realized that the speed of the flow over here is more, and here it is less. Okay, so then he tried to derive one formula to calculate. He realized that it definitely depends on the height. Okay, based on the height, the speed will change. Because if speed was same here also, it means it did not depend on the height. No matter where the water is flowing from, speed would remain the same. But now it is changing with height. The speed obviously is depending on the height. So the diagram for the derivation would be like this. There's a container. So this is the hole created from which the water would flow out. There's a open one. So there's the atmospheric pressure. Rho will be the density of the fluid. And from here to here, this much will be the height. So consider a tank containing fluid. Of density rho. Okay. Sorry, the internet had got disconnected. Okay. So for this, the speed what he gave was the speed of reflux. In this was given as 2gh. Before that, I'll just give the this. then V is equals to root of 2GH. So you have to know this formula also to solve the problems. So if you have any fluid in a container, you know its height. The height should be from the air to the hole. There's the atmospheric pressure. Okay. So the speed formula straight away given is root of 2GH. So now we'll solve some problems based on this. First question. What is the total pressure on the back of a scuba diver in a lake at a depth of 8 meters if the atmospheric pressure is equal to 1.01 into 10 raised to 5 Newton per meter square. This is the first part. Second part, what is the force on the diver's back due to water alone taking the surface of the back to be a rectangle of dimensions 60 centimeter into 50 centimeter. Now what they are trying to say is, suppose the scuba diver is there at this particular, suppose inside the water. Scuba diver means those who dive inside the water. Must have seen those. Okay. Suppose the scuba diver is here. Now consider there's a pressure which is coming on his back. So above him there's a liquid column of height h, suppose. This whole thing, this whole liquid column is putting pressure. So there's a liquid column and there is atmospheric pressure also. So now there are two pressures which are acting on him, this plus this. So total pressure on scuba diver will be T is what? The liquid column plus atmospheric pressure. So that is given as rho GH. Pressure due to liquid column is a fixed formula, rho GH plus P. Now rho is given directly, density must have been given. Or even if it not given, then you know density of water. Okay, in a lake means obviously it will be water. So density of water is 10 raised to 3. Actually, it is 997, but we assume it to be 1000 only. So density of water is to be taken as 10 raised to 3. Gravity is 9.8. Height is given. Depth means is 8 meters deep from the air. So this becomes 8. Height you have to take as 8 meters. And atmospheric pressure what I'll do is I'll make the same as this one 10 raised to 3 into 9.8 into 8 plus 101 2 LUs here and then make it 3. Out of 5, 2 I will use to multiply them. Now 10 raised to 3 is common at both the places, so take out 10 raised to 3 common. Okay, so 179.4 into 10 raised to 3 Newton per meter. Or you can use the word Pascals also. Now second part, how much force has been applied. Area, okay, force is nothing but pressure into area. Because pressure is force upon area. Now pressure is only asked due to water. Area means the dimensions are given, so we have to calculate area. Area will be the rectangle, the length into breadth. So 60 into 50 centimeter, no? Both are centimeter. 60 centimeter into 50 centimeter. So that will be 3000 centimeter square. But we never write in terms of centimeters, we'll have to convert it. 10 raised to minus 2 the whole square. So that will become 0.3. Minus 4 means 4 decimals this side. 4 decimal places. Just put it here. Pressure is already given as 0. Force. This is nothing but inside the water. Put this here. Pressure 7. Oh, this we cannot take. This is total pressure now. Only this has been asked because of water. So we cannot take atmospheric pressure. This is atmospheric pressure and this is due to water. So only due to water will be this column. You cannot take atmospheric pressure because they've specifically asked only of water. If not asked, then total pressure we have to take. But in the question, they've specifically said only because of water. So you cannot take atmospheric pressure. So we have to calculate only because of this. So due to water will be rho. The answer we'll get is newtons. Force unit is Newton. Next question. A tank containing water as a whole of on vertical if the center of the hole is 4.5 meter below the surface of water in the tank. Find the velocity of water discharge. So there's a water tank from top. It is around 4.9 meter. So here will be the hole. We have to calculate the discharge at what velocity means what is v. Height given is 4.9 and there's water, so density will be definitely 10 raised to 3. Density of the water, this is fixed. Gravity is 9.8. So velocity formula just now I gave you that efflux 1 2 g h. Anyways, density is not needed also because here straight away root of 2gh. So 2 is gravity into height. This is not needed. Only if pressure of the liquid column was asked, then we had to calculate. We needed a rho. If pressure of this column was asked, then it would be rho gh. But this is not needed. Only this much. Again, this will be 9.8 into 9.8. 1 will come out now. Same pair, no? Otherwise, you can write it as 9.8 the whole square. The square and root will cancel. So 9.8 meters per second. Next, this the Venturi meter. Keep it like this also, venturi meter. It is a device used to measure the speed of incompressible liquid. So the diagram of a venturimeter looks like this. Just narrows down then. Okay, like this. And this is the opening area. So from here one to measure that U-tube is being used. This is the manometer attached that calculate the pressure. There's a fluid. Here the area is A1. The smaller area here is A2. We can consider small a, capital A and small a. Here with the speed it is entering with V1. Here it is leaving with V2. Okay, the same liquid is flowing out. We want to describe, okay, venturimeter is a tube, or it consists of a tube with broad diameter and a small constriction. It is the word on the textbook. If you don't want to remember that constriction, small area you can say in the middle as shown in figure. A manometer, a U-tube you can say, a U-tube manometer is attached to it. One end is connected to the broad area, other end connected to the constricted area, the smaller one. You can say small area here also. In the previous class, we had seen something called as equation of continuity. Remember, like what I told, suppose if you have any pipe like this, if area is big, then always the velocity will be small. If area is less, okay, smaller area, more will be the velocity. Why? Always A1, V1 should always be equals to A to V2. I've given you example also when we use water pipe in the garden. Okay, what happens is when you try to block the tip of the pipe, means what, you are reducing the area. So if you are keeping the finger, means you are trying to reduce the area. Smaller the area, you must have noticed the water will come with more speed. Okay, so if you increase the area, the velocity decreases, but if you decrease the area, make the area smaller, velocity always increases. Why it happens? So that this product, area into velocity, should always remain constant. So as per the same equation of continuity logic applying here, even though area is big, velocity will be definitely smaller. If area is small, velocity will be more here. So whatever it may be, this into this will always be equals to this into this. So as per equation of continuity, A1 V1 is always equals to A2 V2. Now which areas we are using? Capital A, and this I'm using as small. So what is V2? Now this is equation 1. Okay. Now even applying Bernoulli's theorem, what is as per Bernoulli's theorem, what it says? As per the Bernoulli's equation, total energy remains always same. Means what? All the total energy, the pressure, okay, the pressure, the kinetic energy and the potential energy always remain same. So which is the pressure, on the other side also half V square. So this will be V1. Yeah, everything remains same. Now what we are assuming, that whatever, see, that tube what we had assumed, no? From here, the height anyways will remain the same from the ground. We always consider with the center reference. Okay, from the ground, anyways, height is always the same for that tube or even this. The height will remain the same. So H1, H2 will not be different. If it's a straight line, I told you always the potential energies will cancel because heights will remain the same. If height difference is there, then this will be H1, this will be H2. But if you check the center line, height is same. Density will not change. Gravity also will not change. So this term in the end will cancel. So this side it is, here it is P2. So comparing here and here we are doing. So this will be V2. So what I'll do is I'll bring P2 this side. P1 minus P2 will be equals to Now half row is common, so just take out half row common. Now if you see equation 1, instead of V2, put this value. So P1 minus P2 will be half row I've substituted the value of V2. Now half row, open up the bracket, this will be a square upon a square, V1 square minus V1 square, take V1 square out. V1 square I'm taking common. And just write it like this, minus 1 Now my aim is to find the velocity or the speed. Okay, this Venturi meter is used to calculate the speed. So this speed I'll keep in one place, rest everything I'll take on the other side. Okay, if before that also, what is pressure difference? P2 minus P1 or P1 minus P2, it is nothing but liquid column pressure, no? So instead of P1 minus P, I can use it as rho C H. So this is nothing but of the manometer, that YouTube, no? Inside that whatever liquid is there of the manometer. So I'll just use the pressure of this liquid column will be rho GH. Half. Now keep everything here, take rest of the things on the other side. 2 will go up upon density, this row, because this row and this row can't be same, so I've just used the letter M. And this whole thing also will come down, A upon A the whole square minus 1. So what remains here is only V1 square. And this whole term I'll take on top, so it will become minus 1. And finally just write it under root sign. This is raised to minus 1. And just because they have given like that in the textbook, this root now they have just separated out. So root means always raised to half. So this they have kept under root only. But this fellow A upon A, the whole square minus 1, raised to minus 1 is already there. So what I have done is just raised to half the mA. Root can be written as half. So the final formula of a venturimeter, speed of a venturimeter is so this will get multiplied, will become minus half. So that's the final formula. Okay, one final question, all based on a venturimeter. Similar concept, that is, an aeronautical engineer observes that on the upper arm, lower surfaces of the wings of an aeroplane, the speeds of air respectively. What is the lift on the wing if its area those who some colleges now they might not do problems and all, but later the thing is you cannot avoid this concept because those especially those who want to answer neat and all your CBSE whatever the normal board NCERT board will not see what your teacher had done in college or not. Anyways, now from this point of view, from your now 11th standard passing exam point of view, it's fine. But later you have to know these problems. Take the density. So even if you don't want to study, at least write and keep, because both 11th as well as 12th standard portion you have to know at the end of the 2 years. There is the same reason which we cannot skip certain topics just because your teachers have skipped in the college. Density of air is to be taken as 1.29. Area of the wing is been given as 3.2 meters square. Speed on upper surface of the wing is given as 90 meters per second. Speed on the lower surface of the wing is given as 72 meters per second. Okay, this is actually based on the Bernoulli. So according to the Bernoulli's theorem, just now how we have derived now one formula that we only can use, height will remain the same. Okay, height is to be considered the same, so potential energy will be anyway 0. We can use P2 minus P1 of V1 square minus V2 square into its density. Just now in the venturimeter, whether you do P1 minus P2 or P2 minus P1, it's fine. Because finally pressure, even if you are getting negative, you have to write it as positive only. Okay, so just calculate the pressure difference. So directly V1 and V2 is half. You can use rho this side also, no problem. Just substitute the values straight away. Area is not into picture as of now. Later it will come. What is the lift? Lift means force, huh? How much is the force on the wing? You have to calculate force finally. So P1 P2 minus P1 will consider the pressure difference half. Even if you write, no problem, huh? P1 minus P2. Rho is given as 1.29. Then V1 is given as 90 square. V1 minus P2. So this will be 1.29. 90 will be 8100. This will be 5184. Calculate P2 minus P1. Approximately you'll get 1880 after calculation. Now this is pressure difference. Now force has been asked. Force is always equals to pressure into it. This is the pressure, total delta P. Or lift. So that is given as 1880.82 and area already given as 3.2. Calculate. So 6018.62 Newton will be the answer. Okay, with this I finish with the chapter. Here and there small, if in case problems I find later in the question papers and all, while revising the chapter, final revision time I'll solve. In case your teachers are solving any questions, problems and all, please send so that I can solve.